Today we're talking about empowering mathematics education in high priority schools. Teachers will review the 8 standards for mathematical practices, select rich mathematical tasks, and design a plan to incorporate those tasks in the student-centered learning environment. You write down 2 facts about yourself. We're going to write down 3 facts, but 2 of them are true. Well, 2 of them are true, 1 of them a lie. We have to guess which one is not true. So, I am happy that I now weigh 135 pounds. Okay. I have 12 sisters, and I studied abroad in England. Most of us, if you don't, we brought some for you today. The 8 mathematical practices. So here, number 1, make sense of problems and persevere in solving them. Reason abstractly and quantitatively. 3, construct viable arguments and critique reasoning of others. 4, model with mathematics. 5, use appropriate tools strategically. 6, attend to precision. 7, look for and make use of structure. And 8, look for and express regularity and repeated reasoning. These standards are for the student. So I'm going to focus on perseverance, and make sense of problems and persevere in solving them. We got a video for you. When you watch the video, on the back of your card, you wrote your 2 truths and a lie on. I want you to focus on these 2 questions. Number 1, what is the effect of explicitly focusing on perseverance skills on the student? And then, don't worry about that. 2, how does Ms. Noonan, that's the teacher in the video, differentiate to present appropriate challenges to each of her students? And I want you to think about, does this relate to our SEL model? Because it's not an SEL like, we are unique. But can we relate what we see on here to what we do at Brenda Scott?
I'm Madeline Noonan, and today in our math class, it's all about perseverance and cutting a cube. Perseverance. So 5th graders, we're going to just start with something called a problem of the month. So I think what's great about this problem of the month is that it's just a really perfect vehicle for this practice standard around perseverance.
And I said kind of like it just allows them, this is where you need to be, this is a skill we're working on. It like everybody's working towards the same skill, everybody's going to be feeling the same, so it's not just you. Don't worry, explaining to them that perseverance is not easy, it's hard. That type of thing, letting them know that they're free to kind of focus on actually completing the task instead of be like, oh man, this is hard. We hear a lot of kids say, this is hard all the time. So yes, it's hard, and you acknowledge that explicitly. It's going to be hard, but you can do it. So yeah.
I also put down that basically that a plan has to be in place. Because you won't spend the whole time complaining about how hard it is and not have a plan and strategies. And of course with that, communicating, I like that the young lady in the video was asking a group to communicate with each other. This is not a one-sided deal where it's just myself, and if it doesn't work with my strategies, I can communicate, and maybe somebody else will bring a different spin on things. So communication, definitely, but plan, strategy, and being able to communicate.
And with this video, what we really need to work on when in the math class is dialogue. Kids need to be able to talk and express. With ELA, we're always talking, always summarizing, whatever. It's just like different. But with math, we never really have a lot of dialogue, and we need that. So the kids were having it. The teacher really was facilitating, asking open-ended questions, putting it really back on the student.
The next 7 slides basically touch on what you saw in the video and actually what we already discussed. It's going to be very important that you take notes following the next 7 slides because you're going to have to select one of the standards. Reason abstractly and quantitatively. Like I said, you probably saw this in the video where the students, they made sense of the quantities and their relationships. Well, why does this segment, how does that affect this part? If I cut this area over here, what's going to happen? And basically that was the next lesson. In my mind, it looks like she was just having them to work backwards, you know, to unfold that cube to see what is that net going to look like. Represent symbolically, manipulate equations, attend to the meaning of quantities, not just compute them. Understanding using different properties and operations. So they were doing a lot of different things to understand what is our goal, what is our task, what are we trying to do. We have to use a lot of different methods to figure out where I'm supposed to cut. Viable arguments, construct viable arguments and critique reasoning of others. You saw, like Ms. Jones was saying, a lot of dialogue. And then they supported why I'm making this conjecture. Understand and use definitions and previously established results when justifying results. Attempts to prove or disprove conjectures through examples and counterexamples. Well, I think this might work. Well, why won't it work? Because of X, Y, Z. Communicates and defends their mathematical reasonings using objects, drawings, diagrams, actions, verbal and written communications. And you saw all of that in the video. Modeling with mathematics. Solve math problems arising in everyday life. Apply assumptions and approximations to simplify complicated tasks. Use tools such as diagrams, two-way tables, graphs, flowcharts, and formulas to simplify tasks. Analyze relationships mathematically to draw conclusions. Interpret results to determine whether they make sense. Standard 5. Use appropriate tools strategically. Decide which tools will be most helpful. Do you need a ruler? Do you need a calculator? Do you need a protractor? Detect possible errors by strategically using estimation and other mathematical knowledge. Make models that enable visualizations of the results and compare predictions with data. Okay, you said this is the answer? Well, back it up. Use technological tools to explore and deepen understanding of concepts. Standard 6. Attend to precision. Communicate precisely with others, and you saw that a lot. That was heavy in the video. The students, as Ms. Jones was saying, they were talking to each other. They were thinking it out, and I think I will admit that I am one where I just like it quiet, but I have to get out of that mode. And I have started, I'm not going to say that I'm a pro at it yet, but I have started after my do now. I tell my students, talk to your peers about what the answers are. Let's find out who has the answers wrong and who has them right, and then why. And then I send students to the board. Use clear definitions and discussions with others. State the meaning of the symbols consistently and appropriately. Calculate accurately and efficiently. Accurately label axes and measures in a problem. Look for and make sense of structure. Look closely to determine a pattern or a structure. Step back for an overview and shift perspective. If your answer is wrong, redo it. Step back, reconstruct your roadmap, reconstruct your processes, and then go forward. See complicated things and being composed of single objects or several smaller objects. Look for and express regularity and repeated reasoning. Identify calculations that repeat. Look both for general methods and for shortcuts. A lot of the times, there's not only just one, as we just keep using this word cookie cutter, there's not one way to do math. Everybody has their own conceptualization in their mind of how to do a problem. Maintain oversight of the process while attending to the details. Continually evaluate the reasonableness of results, and that's a continual thing. You're going to select your standard, okay? You're going to go to this website, insidemathematics.org/index.php/Common Core, and it looks like 3 M's. core-math-intro. And this is a professional development, a mathematics professional development. And on this site, you have headphones next to you. On this site, there are going to be the 8 standards listed. And whichever one you might want to begin to implement in your classroom, and this is not a directive in any way, but if you would like to try to implement one of these standards, as baby steps into your classroom, you're going to pick that one. We're looking for components, right? The components of the classroom. So based on the standard that you selected, what components of that classroom would you see? So say, for instance, the technological tools, right? What types of items would you see in that classroom? How would the classroom be designed? Where would the desk be placed? Where would the teacher's desk be placed? All the technological tools that would embody a classroom that promotes that standard, what would it look like?
Okay, not exactly what we said.
Usually at the science table, usually some lame chart that's not.
Really? Number one, go ahead.
Okay, so we had make sense of problems and persevere in solving them. So a classroom that would promote that is collaborative. So that's why we put the circle tables in to give the students a feel of like, this is a community conversation that's taking place. And each of the students would have whiteboards, which is what Ms. James used in her class, where they could, jot stuff down and then quickly change it if they need to and erase it instead of dealing with papers and pencils popping and sharpening pencils and all of that. So they would have whiteboards individually, and then there would be easels set up next to each of the tables where once they had a chance to figure out individually what they were thinking, they would collaborate on those together.
The problem-solving rubric, I was thinking it was more so for middle school, but it would be dependent upon their level. So you're right, it could be for, either level. So based on what we saw, this is a cooperative task that we want you to engage in. We want you to discuss the strategies that you're going to use. We want you to draw diagrams. We want you to construct plausible arguments. Just everything that we have talked about thus far, we want you to utilize all that while you're going through these problems.
You had a quick chance to look at all three activities, and then if you even glancing at them, you can tell by the verbiage, the pictures, that they become increasingly difficult, if you will. If I were teaching in a traditional school, in a traditional grade 6, I still would hand out a packet that looked exactly like this. Because in a traditional setting, you'll have students in your classroom who need to go through the motions of the second grade assignment to either help them review or to actually learn something so that they can be more confident with the harder activity.
I ask you to please recall a time when you really loved something, a movie, an album, a song, or a book, and you recommended it wholeheartedly to someone you also really liked. And you anticipate that reaction, you waited for it, and it came back, and the person hated it. So by way of introduction, that is the exact same state in which I spend every working day of the last 6 years.
I thought that video fit right in with what we're trying to create here. I want you guys to research and use some of your skills to find or come up with in group, probably, well, because I'm looking around the room, we pretty much got a variation of levels here, something within your level or at a level you think you want to get to sometime in the spring, a rich task problem.
We actually looked up Robert Kaplinski, and they had a model of Pac-Man, which we knew would engage just about everybody in our population. And it went from low end all the way up to high end with rotation, translation, using some of the mathematical terms for them to explain the movement of Pac-Man, where does she start. They also did like a coordinate grid where you have to identify the location. So definitely provoking thought, because a lot of the kids are gamers and know all of the characters and all of so a point of interest to them definitely would be the game, but because that would be the hook and grab, that could take and lead you to many other things, and having them come up with questions of, where did she move to, or where did he move to, how far did he go, what conclusions can we draw, what assumptions can we make. So all of those things, and being able to even identify for them, what does those terms actually mean? Conclusion, assumption, rotation, translation, reflection, and all of those things to kind of talk about so that they have the vocabulary and the academic terminology to help assist them when they're working through problems.
We got a really cool, what was the website we?
The website that we were on was the Illuminations.
And it was really cool, project called Snap Hotel. And the premise was the kids get blocks, you know, they like to play with blocks, 50 blocks, and they had to build a hotel. Snap cubes, blocks, snap cubes. We can't afford snap cubes. Okay, they had to build a hotel using these 50 snap cubes, and some of the questions would be, you know, how many snap, not how many, you have 50, build the best hotel you can. How much are you going to charge for a room once you build it? How much is it going to cost to build a hotel? So all of those kind of questions, like problem solving, figure it out. You working with your partner, you have to figure out what is the most economical hotel you can build. What's going to cost you the least to build, and how can you make money off that hotel? So profit, gain, all of those
And
things.
to take it to a higher level, it can also be done where, well, they could calculate the cost for a room in the hotel based on the cubes that they use, because each cube, each roof, each window all have different pricing. But to take it to a higher level, they could also calculate which rooms make the better profits. And then also they were talking about how you could then also take it to another level, have them calculating the taxes for the rooms in the hotel. That was good.
We also like to really thank everybody for coming. We're really happy that you all came out, because it just shows that, you know, teachers are just not all about talk. We're about really doing. We will take our personal time to learn new things and do discussions so that we can improve in the classroom.